Hello everybody. In this video I will discuss problems with hypothesis testing for population proportion, and I will also discuss two different types of errors that can be made when conducting a hypothesis test. Okay, so just like before with hypothesis testing for population mean, we will be using p-value method. Okay, now there is a critical method which is equivalent to the p-value method discussed in this video, but I will only require you guys to know the p-value method. So we need to check the conditions. We have a simple random sample. We have the sample size condition. So in this case it's n times p is greater than or equal to 10, and n times 1 minus p is also greater than or equal to 10. And the population needs to be at least 20 times as large as the sample. And what is the procedure? We state the hypothesis. We use one proportion z-test command to find the p-value. And if the p-value is small, we reject the null hypothesis. Otherwise, we fail to reject the null. Okay? So let's go ahead and solve the following problem. Okay, so what is this problem about? We have a report from 2010 that says 20% of all Americans smoke tobacco. And then a random sample of 400 Americans found that 76 of those smoked. Okay? We're interested in testing whether the population proportion of Americans who smoke has changed from 20%. All right? So one thing you can do is the following. You can actually see how this new proportion is different from 20. So 76 out of 400. What is this? So this is about 19%, right? So 19% of that sample smoked tobacco. Is it different from 20%? Well, yeah, it is. But is it different significant enough? Okay? And that's the question that we're going to answer. So let's go ahead and solve this problem. So this would be problem 3. Okay, in this case my P is the proportion of Americans who smoke tobacco. Okay, you don't have to write this all out, but I think it's a good idea to kind of understand what your problem is actually talking about. Okay, so what is my null hypothesis? Let's go back to the problem. The null hypothesis says that in 2010, the proportion was 20%. So I'm going to write P is equal to 0.20. The alternative is in the question. We're interested in testing whether the population proportion of Americans who smoke has changed. So that means I need to write P is not equal to 0.2. Okay? All right. So what else do I have? I have a sample of 400 people, right? Sample of 400, and 76 of those smoked. So X is 76. My level of significance is alpha is equal to 0.10. So that's the number that I will be comparing my p-value to. Okay, so I'm going to use one proportion z-test to conduct my hypothesis testing. Okay? Alright, let's go to stat, test, and it's command 5. And then we have P naught, that is your value that's accepted to be true. X is the number of people that smoke tobacco, so this is 76. And the sample size is 400. The alternative hypothesis says not equal, so that's good. Let's go ahead and compute this p-value. The p-value that we get is pretty large. Let's take a look. 0.6171, right? So 0.6171. That is definitely greater than 0.10, which is your alpha. right? 0.6171, that's a very large p-value. So what is the conclusion here? We fail to reject the null hypothesis. There is insufficient evidence. There is insufficient evidence to conclude or to claim that the proportion of Americans who smoked changed. So the proportion of Americans who smoked has changed. Okay? Basically we're saying no, it did not change. Yes, 0.19 is different than 0.20, but it's not significantly different. All right, so that's what we do here. Okay, so before I move on into errors, I would like to discuss the following situation. What if this problem did not tell us that we have 76 people? Instead, what if this problem said, well, in this sample of 400 people, we found that 19% of all sampled people smoke cigarettes or tobacco. Okay? Sometimes this can happen. So sometimes your problems will look like this. What I see happens very often in your calculator for the X, I see people plug it in 0.19 and trying to conduct hypothesis testing. If you're going to do this, you're actually going to get an error on your calculator. Okay? Because X has to be a whole number. This is the number of individuals. Okay, so it needs to be an integer. So what you need to do in this case, X is not 0.19. X will be 0.19 times 400. Okay, and once you compute this, now in this case we'll actually get exactly 76. But remember always to round it up. Round it up. Okay, because these are people that we're talking about. So we'll round it up. And that's a common mistake that can happen. Now let's go ahead and talk about two types of error that can happen when conducting a hypothesis test. Okay, so let's talk about types of error. And I think this concept is easily understood if you consider a criminal justice case. So for example, let's say we have a defendant in court. Okay, now in criminal justice, by default, every defendant is innocent until proven guilty. Okay, so let's take a look at this following table here. So the top row will represent the reality, okay, which usually we don't really know what the true reality is, right? So let's say the defendant is innocent. Okay, this is equivalent to your null hypothesis. So this is your null hypothesis. By default, everybody is innocent. Okay, and then also could be guilty, right? We don't really know which one is true. So innocent person, and this, let's say, represent this. This is representing decision. Decision. Oops. Okay, so let's see. This is decision. Okay, so let's say that the prosecutor collected some evidence, presented it to the jury, and the jury makes the verdict, right? So they say, okay, we decide that the defendant is guilty. Okay, so what do? They reject H0. So what happens here? Okay, so they say that the person is guilty, right? They say he's guilty, when in reality he or she is not. Okay, so what happens? We're sending an innocent person to prison potentially, right? Or maybe giving him or her a fine of some sort. So this is equivalent to type 1 error. So this is your type 1 error. Type 1 error. Rejecting the null hypothesis when it's true. That's type 1 error. Okay. Now let's say the jury said, okay, we found the defendant not guilty. Okay, so they failed to reject it. Failed to reject H not. Okay, so not guilty. Then this is a correct decision, right? So this is a correct decision. That's not a mistake. Okay. Now let's say the person is guilty. What happens then? If the jury says, okay, we failed to reject the null hypothesis. Okay, what happens? Fail to reject. That means that's this situation right here. When the person is guilty, but the verdict is not guilty, then the guilty person goes free, right? Okay, so they say not guilty when in reality he or she is guilty. This is also an incorrect decision, right? So this is type 2 error. Type 2 error. Okay? And then what's the only other thing that can happen? Well, if he or she is guilty and we reject the null hypothesis, then this is the correct decision, right? So this is correct. Okay? So how would I write something like this when it comes to problems in statistics? Okay, so let's go back to the problem that we discussed just now about proportion of Americans who smoke tobacco. So we have our hypothesis here. These are our hypotheses, right? So the null hypothesis says the proportion is 20%, and the alternative hypothesis says, well, it's different. Okay, it's not 20%. So what would it mean to have type 1 error in this scenario? Okay, so let's say I conducted the hypothesis. Okay, then what would it mean to make type 1 error? So let's do type 1. Type 1. Okay, in the context of the problem, it means the following. In reality, the proportion of Americans who smokes tobacco is 20%, but we concluded that it has changed. Okay? That would be a type 1 error. What about type 2 error? Okay, so type 2. Type 2 error means when the null hypothesis is false, but we fail to reject it. Okay? So, in reality, the proportion of Americans is who smokes tobacco is what? Is not 20%. So who smoke tobacco is no longer 20%, right? But we concluded that it hasn't changed. Okay? So, your type 1 and 2 error will really depend how you set up on the null and alternative hypothesis. Again, type 1, what is it? When H not is true, but we reject it. Okay? That's your type 1 error. What about type 2? H naught is false, but we fail to reject it. Fail to reject it. Okay, when can this happen? So type 2 can happen when we don't have strong enough evidence to conclude that H naught is true, right? So it really depends on your sample. In statistics, it depends on your sample and how good of a sample you collect. All right, so that's how you would write a conclusion about two different types of error that can be made using hypothesis testing for statistics problems. Okay, all right, thank you for watching.